Hello everyone, March 27th. Max number of points from grid queries. M by n integer matrix and an array of queries. Find an answer of size k such that for each integer queried I, you start in the top left cell of the matrix and repeat the following process. If queries I is strictly greater than the value of if queries I is strictly greater than the value of the current cell, then you get 1 point if it is the first time you visit the cell, and you can move to any adjacent cell in all 4 directions. Otherwise you do not get any point and you end at this. So we basically, if it's bigger, strictly greater than the current value, then you move forward and you get a point. Otherwise you stop. After process, answer I is the maximum number of points you can get. For each query, you are allowed to visit the same cell multiple times, but only the first time counted. Return the result array answer. So okay. So our grid is like this. 1, 2, 3, 2, 5, 7, 3, 5, 1. And the first query q is equal to 5. So if it's 1, I can go. Right, 2 I can go. And essentially, because it can go anywhere, right? I only get point if the first time. So if like it's 5, so anything smaller than 5 has a full range to go. So I can visit all of these. So it's gonna be 1 plus 2 plus 3, that's a 6. That's an 8 and that's 11. So the first one shall be 11 unless we're finding a different result. What? Answer is 5. Oh, you get 1 point. Alright, so 1, 2, 3, 4, 5. Yeah, okay, you get 1 point. And now q is equal to 6. So we expand 8. Equals 2. So we just get 1. 3, we get 0. So what we are saying is basically you're starting from the top left corner and you want to find all the nodes that can be connected. Just like how many nodes can be connected? That's the question. How many nodes are connected? Right? And the restriction is 1000. So O(n) squared is good. Well, but naive solution is O(n) squared times k, which I really don't think is the answer, because k can be good, can be very big. Right? Okay, so we have to reuse the previous solution, that's what I think. Or you can sort query. Right? If you sort query, then the smaller ones, yeah, we just go smaller ones and we find the edge of where they can go. and you will just expand based on that. Right? You just expand based on that. So we go through the ones that did not get in contact. Okay, well, how do we handle this? So we can maintain, let's say, a queue, and on the queue we will place the nodes that have an edge to the outside. Okay, so in this case, queries are sorted first. I go with 2. Okay, so I go in here. It's good. This is the first one, right? So first one, yeah, you check the first one is good, and you put it in the queue, right? And then this gets popped out, and then you look around, see, nothing gets in, and then and then the queue ends, right? But we need to keep the queue. The queue cannot end. Huh. So we don't pop. We just go through everything in the queue, right? We do it like an array, right? Like an array. So we go through every single one. Yeah, in this case it's just 1. We always put in a queue. We say while queue for everything in the queue. Right, so we're visiting it. So if it's smaller than the query, that means we can visit it. Right, we can visit it, and we'll add that to the result, and we'll have find its neighbors that has not been visited before. Right, or find neighbors that has not been visited before. Okay, so we find a neighbor, and now we check if it's good. If it's good, we put it in the if it's good, we put it into another array. If it's not good, then we don't do anything, right? And then we have the next round, and then we'll try it again. Then we have the next round, right? Until we hit a point where we don't have the next round. Then the current round we'll start with the current round for the. Yep, I think this will work. So like this one, we go this, right? And then we basically just 1, because we have nothing else. So 1 will come into the next. So start from 1, I go again to its 2 neighbors. And this time it's good, so we get 2. And from 2 we'll go, from 2 we'll go to 3. Then 2 we get, we don't do it anymore. Oh, so as long as it has edges that you cannot do, we don't remove it. Don't remove it. Let me think again. Yeah, I think hardest thing in this case is just the don't know what can be included and what cannot be included. I don't want to redo the things. Because if I use a queue, right? So I start with 1, which is fine, and then 1. How do I decide if one is all visited? Because I just need to know the front, right? The edge. That's what we want, the edge. So 1 will count how many, how many it should. Alright, and then we count how many it will go to the next round. So if the number go to the next round is the same as the connected ones, then that means it has succeeded in getting everyone out, so you can remove it. Okay, so that's the only way that will remove it. Okay, so that's when we remove it. But in this case, we start with this. Visited it, but nothing can do. Okay. So next one will be the same. Come out. They go to the neighbors. Good. And then they're all good. So yeah, we can just put it back in the queue. We can put it back in the queue. Yeah, so we get it out, and then we check. Okay, we check its neighbors. Now they're all good, so I push it in. Now 1 gets pushed out. Okay, 1 gets pushed out. Because 1, I can set the grid value to -1, so 1 gets pushed out. So we have 2 and 2. So for 2, I can go to all 3. Right, but one of them has been visited before, so I have a scene. I visited. Right, I visited. I have something visited. And then we'll go around, count how many should and how many in total. If it's good, then we don't include this one in the next round. We set it at -1. Okay, we set it at -1, so which means it has been taken out. And then we just have to go through this thing every single time. I don't know. I don't know if it's gonna. So we have to go through every query, and for each query we have to go through not the entire thing, right? Not the entire thing. I can give it a shot. Okay. Alright, so I sorted. Now we're just gonna go for every single one. Actually, I don't think I need this. I can just say auto const pair of guess I cannot do that. Right, and then we have index. Alright, so we have this. Now what? So we have a queue. We go through everything in one. Try to see who can be in it. So you put it in the back. And then if it doesn't work, I'll push it back again. If it works, then it just works. And we just need to know what the current index. These are the. We want to know what more ground has been broken, right? That's what's interesting. Like based on the previous, what's new ground has been broken. I do need a queue, a deck. And on the deck, it has to be a pair. Alright, so queue is ready. Oh. So I go through everything one, pop out, and then try to see how many we can do. So every time we pop out, we check. If it satisfies, we'll add it. It's the delta. And all that cannot. Yeah, shall work. So I'm gonna go through every one, and then we'll pop out. Right? When pop out means this one will handle, and then we'll add it. So first thing we say res index plus equal to pre. Yeah. And then pre, that has to be new, right? Because this will have this, and then it has to be not the new, to break a new ground. Okay. Then we say auto current we can say this is q dot front. Now pop it. Alright, so you pop it, but this doesn't count, right? It doesn't count because this is the very beginning. Then what do we count? Additional. Because at the beginning is everything, right? It's everything. And then moving on, it's not. At the beginning, it's everything. Okay. Well, put something that's not part of this world. So if I start with this, right, then we can do delta. Okay, this is a current. Oh. And then this is the delta. Right from this, we try to get out. Ah. 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 Okay. Alright, I got the IDJ. It cannot be seen. Current. Okay. This is the next. If an x cannot be visible before, and it's smaller than k, that's a count. Right? And that's not a count. So we got a current, and now we just do, so we should simply is obsolete. True. So what of the work that will be false? Ah. Ah. Alright, so this is a sign that we shall go. One more. Oh, one more day. Oh, if it's satisfied for all of them. Right, if it's satisfied for all of them. Then this is we expand. So right, we expand, and this will go to the right. You put this there, set it to -1, so you if you won't push both of them in, right? And then we'll push back this because this is basically this is the next. This is the additional, right? This is additional, and if you cannot do it. Okay. So this is good. So I include it in the current round, right? We just expand, we expand, and then they go there, and then those that haven't fully. I still think we should count. Because this one doesn't work. Oh, maybe this one does work. Hold a second. We have to do this one first. Right, we do this one first. This is just the requirement. Right, this means you can go. So okay, we go there, then we check. So if grid nij is smaller than k, then we say this is a good one, it's a good thing. Right, then we do all the things that we say we will do. right? So if it's smaller than k, then we can go. So we set that, we push this in, so it can go for the next round, right? And if it's else, then I said is obsolete, it's false. Okay, so now it's a false. This is to delta. What's delta? Oh, it's delta. So yeah, this is current node. So once you get out, we need to check. If it's not obsolete, then q.pushback current. Right, I'll have to push current back. I'll have to push the current back because it has not been obsoleted yet. So this will give us the current res, right? The current res, and once all this is done, right? So we go through every single one on the current thing. We record to make it bigger, so we have the res index be in the current count. I say pre equal to res index, right? Pre shall equal to res index, and we'll keep going. And we'll end prematurely, right? So basically we want basically this is go through everything in the queue, right, and then come out. Then if it's not possible, then we'll have the nodes and just they cannot progress. So the next one will go in, we'll try those again. Next one go in, we'll try those again. Next one go in. So every time we go in, we'll try those again. And if it can get out, then we'll just add more. I will have to times 4. There's some repetition. How about the queue? I think I don't really worry about the queue. The likelihood this will be correct is very low. Yep. Where? Didn't even show me. Oh, it's here. I don't need this one. Ah. 6. I'm missing 2. So I got 1. But a Q should be 1. Alright, this 1. And then next will be should be 4, right? I didn't keep going. I see. Yeah, we should keep going until has new.